Okay, day 2, guys. We could do this. Okay, so yesterday, I don't know if you figured out the pattern, but that's what we're going to focus on today is the pattern. Okay, let's go back and look. Yesterday when we had our problem, we had our picture like this. So we had our focus here, and this is our vertex, and then we decided it was 3, 6, and then here's our directrix, and then that random point. So if you notice on each of these problems, on the first set of ordered pairs, we have x and y on the front, and the same for the second. So that's our pattern that we're going to stick with. Now we have to figure out where we got the 3 and 4 and the x and -8 from. So if I look back here, my 3 and my 4 came from my focus. And remember, it is distance, so we always subtract. So it's the focus on the left, and then on the right-hand side, my x and my 8, oh, we got that from our directrix. So that is x and 8 from our directrix as the second numbers. So directrix on the right. Okay? So we're going to apply that to today. Now, the directrix is not written as an ordered pair, and also, if you notice, this time instead of just x equals, we have y equals. So the first thing we need to talk about is whatever letter the directrix has, that's what you solve for. So solve for this letter. Okay, and that'll be more important towards the end. So now we need to create an ordered pair for our directrix. Well, if we were creating an ordered pair, it says x is equal to 2. So y, we don't know, but we do know that x is equal to 2. So now we have an ordered pair. So on the first side, on the left side, we have our focus. Remember, it's x, just an x, because that stands for our point that we don't know, minus our x value, which is -2, and y minus our y value, which is 0. So this is the left-hand side. On the right-hand side, again, we have x minus our x value, which is 2, and y minus our y value, which is y. And now we solve. So we don't have to draw a picture every single time. We can skip those steps if we knew the pattern, and this is the pattern. So remember, the first thing that we're going to do is square both sides so we can cancel out our radicals. And then x minus -2 is the same thing as x plus 2. Y minus 0, oops, heavens, plus. Y minus 0 is the same thing as y squared. X minus 2 squared, so I'm just simplifying, and y minus y goes away. Okay, so now we have to distribute. So we have x plus 2 times x plus 2 plus y squared equals x minus 2 times x minus 2. X times x is x squared. 2 times x is 2x. 2 times x is 2x. 2 times 2 is 4. So I'm just distributing this x to each term and this 2 to each term, okay? Just quickly because we are good at this. The same thing over here, this x to each term, so x squared minus 2x, and this -2 to each term, so -2x plus 4. And then we simplify. I can take off an x squared on each side and make those guys go away. And I can also take a 4 off on each side and make those guys go away. Sorry, I'm going to write underneath this problem. Okay, so we have 2x and 2x, that's 4x, and y squared is equal to -2x. Now, we have to remember what we said at the very beginning. Solve for this letter. So this letter is x, so we're going to solve for x. So basically, the squared should be on one side and the not squared should be on the other side. Like, the squared should have all the business. This one doesn't have a lot of business, but... So what we're going to do is we're going to minus 4x on each side. So now we have y squared equals -6x. And we're going to divide each side by -6. So x equals -1/6 y squared. So we solve for x. And this is the equation with a focus and a directrix of -2, 0, and x equals 2. do it again. Okay, number 4. So for this one, again, it's square root. Focus is first. X minus our x value squared, and y minus our y value squared. So that's the left-hand side. On the right, we need to create an equation. So it says y is equal to 4, so x is unknown. Or not an equation, an ordered pair. My goodness. Okay, so now we have x minus x squared and y minus 4 squared. Okay, and then here we go. The first thing we do is we square each side to get rid of those little radicals that we got going on. So we have x minus 3 squared and y minus 8 squared equals, that makes 0, y minus 4 squared. This time we are solving for y, like you did yesterday. So this is the same thing as x minus 3 times x minus 3, and this is the same thing as y minus 8 times y minus 8. And now we have y minus 4 times y minus 4. Distribute x times x. So again, here like this. So we have x squared minus 3x, and distributing that guy, negative 3x plus 9. Again, distribution, y squared minus 8y. Notice the repeating pattern, negative 8y plus 64. Again, y squared minus 4y, and last, negative 4y plus, 16. You're gonna fit. Okay, simplify. So usually a squared can get canceled, minus y squared. Again, I'm gonna creep down a little lower. Okay, so we're solving for y, which means I want x and all of the business on the left-hand side. So I'm gonna move my 16 over here to start. And I'm going to combine my 9, my 16, and my 64. So 9, oh no, heavens. Come on, radicals. 9 plus 64 minus 16 is 57. So I've got x squared minus 6x plus 57. Goodness. Minus 16y equals negative 8y. So I'm just combining some like terms. Again, we want to put our y's together because we're solving for y. So x squared minus, not 8, 6x plus 57 equals positive 8y. So then we're solving for y, so we're going to divide everything by 8 and reducing where we can. So y equals 1/8 x squared minus 2 goes into 6 3 times, and 2 goes into 8 4 times. And 57 eighths isn't. That's not going anywhere. All right. Oh, sorry, there it is. Okay, let me know if you have any questions. Have a great day. Bye-bye.